resolution. Suffice it to say, the car is constantly resolving interactions in a city like San Francisco. Unlike straight road driving that you might see in an empty suburban street where there's really no interactions to resolve, there are tons of interactions going on all the time in cities like San Francisco, and these interactions live exactly at this intersection of world understanding and decision making. So what's happening in these two scenes? In the first one, it's simple. It's a presentation of what the AV's decision is when it decides to yield and how the world evolves, future one, to that action. But it's not sufficient to just consider one possible future. We actually need to consider two possible futures in this case, in which the other road user coming from 12 o'clock actually decides to go straight versus yield. In the second example, we do a rollout where the AV actually decides to assert into this intersection. What you see in these two examples is us scoring the difference between these two interactions in real time, understanding what happens if we assert into this intersection, what space does the other vehicle operate, versus what happens if we yield in this intersection, what space does the other vehicle occupy in that case. We need to understand both of these when we do our scoring, because we also don't want to incur undue road discomfort for other road users, and we want to behave safely and comfortably for the people inside our car. So this is how interaction resolution works in real time. As you can see, this is not just actor pairwise. It's simplified in this picture. This is every single actor on the road, not just for this one. And at a four-way stop, you can imagine at the very least there's three other actors to consider if it's a full four-way stop. So how does this work in the real world? This is a really interesting example. I love watching this one because it actually shows the density with which we need to resolve these interactions in real time on the road. So we first drive around this box truck, not a very difficult interaction to resolve. We're pretty sure it stopped. But then you'll notice as we approach this choke point that's created by the fire engine with the cones around it, we see two actors coming from the opposite direction. And we stop and we let them go through. Now when the third actor comes, we actually assert through this choke point because we actually are understanding in real time that we can occupy that space, and if we do, that they are predicted to yield. As you can imagine, if we're not doing this real-time interaction resolution, we wouldn't be able to resolve situations like this. The other interesting thing I want to point out about this example is